Hi everyone, today we will see the question paper Physics paper 3 0625 bar 33 May June 2023. The first question is Figure 1.1 shows the distance time graph for an engineer's journey. She drives from her home directly to her office and parks the car. She then drives from her office to her friend's house and then parks the car. Determine the distance between the engineer's home and her office. So from this graph, we can see he's starting from her home, then he's reaching the office. So it is a distance time graph. So the distance here it is 60 kilometer. And then she parked the car. So here you can see it is 60 kilometer. So the distance is 60 kilometer. The engineer's office and her friend's house. So we need to find the distance between office and friend home. So here she is parking the car. Then from here to this point, that is the distance from office to friend's home. So we can calculate here. So this point, so this is actually 20 and this is 60. So the difference will be 60 minus 20. That is the distance. 60 minus 20 means it is 40. We can write it here, 40 kilometer. Next, determine the time taken to travel between engineer's home and her office. So, engineer's home, office, what is the time? So, this is the office point. So, here the time it is, suppose we are drawing the graph, it is around 2 hours. The engineer's office and her friend's house. So, we'll see the time here. So, this is office and this is friend's home. So, the time here we can calculate it as this is actually 7 and 10. So 10 minus 7, that is 3. So the time is 3 hours. Calculate the speed of the car between the time 7 hours and time 10 hours. So speed can be written as speed is equal to distance by time. Here the distance is 40 kilometer divided by time is 3 hours. So 40 by 3, that is 13 kilometer per hour. 7 to 10 means that is actually from office to friend's home. So here the distance covered is equal to 40. That is 60 minus 20. And the time taken is this much, this time, that is 3 hours. And this distance, that is 40. Figure 2.1 shows an engineer working with wind turbines. Complete this sentence describing how electrical power is generated by the energy in the wind. The source of wind energy is sun. The ultimate source of wind energy is sun. Actually, the wind is primarily created through the differential heating of sun. So we are telling the source of wind energy is sun. When the blade turns, the electrical power is generated using a generator. Power is generated in the generator. Describe two advantages apart from the cost of generating electrical power by using wind turbines compared with using coal-fired power station. So in coal-fired power station, we know pollution will be more. So here air pollution is not there. And we are using renewable source of energy. The energy source is renewable. We are not using any fossil fuel. It is not contributing to global warming. Next, a student balances a beam on a pivot. They then balance a block A and block B on the beam. So this is block A, this is block B. The weight on block A is 0.14 Newton and show that the moment of block A about the pivot is approximately 0.8 Newton. So we know moment means moment will be equal to force into perpendicular distance. Perpendicular distance from the pivot. So here force is given as 0.14 Newton and the perpendicular distance it is 5 point. From the pivot it is 5.5 centimeter. So into 5.5 centimeter. So while multiplying we'll be getting the answer 0.77 Newton centimeter, that is approximately equal to 0.8 Newton centimeter. So we have shown the weight of the block B is 0.19 Newton. Calculate the distance between the pivot and the center of block B. So here we know sum of clockwise moments will be equal to sum of anti-clockwise moments. So here clockwise moment, you can take this one. That is this force into this perpendicular distance 0.14 into 5.5 and here D into 0.19. So 0.14 into 5.5 that is equal to D into 0.19. So we can take this downside. We can write it as 0.14 into 5.5. That is already we have calculated here. That is 0.8 with multiplication when it is coming to Opposite side it will become division. So here you can write 0.19, that is equal to D. So 0.8 by 0.19 is equal to 4.05 centimeter, or you can write it as 4.1 centimeter. Next, the weight of the block B is 0.19. Calculate the mass of the block. So mass can be calculated as mass is equal to weight by gravity. Weight is given as 0.19 divided by gravity is constant 9.8. So you'll be getting the answer as 0.019 kg. Next, a tight fitting lid keeps air inside a metal can. The airtight rubber bung holds a liquid in glass thermometer that is inserted through the hole in the lid as shown in figure 4.1. State what happens to the liquid in the thermometer when the air temperature rises. So normally temperature rising means the liquid will expand. The liquid will start expanding. The temperature of the air is 18 degrees Celsius. Calculate the temperature of air in Kelvin. So for converting degree to Kelvin, we need to add it with 273. So 273 plus 18 is equal to 291 Kelvin. The can is placed in a refrigerator. The temperature of the air inside the can decreases. State and explain what happens to the pressure exerted by the air in the can. Use your ideas about gas particles. So, when you're keeping inside a refrigerator, normally the pressure will decrease. And these particles loses its kinetic energy. Movement will decrease. So, as the particles are slower and as the movement is decreasing, the kinetic energy of the particles will be less. And there will be less collision. Collision also will decrease. As the movement is less, collision also will be less. The air in another can exerts a pressure of 1,02,000 Newton per meter square on the lid. The area of the can lid is 0.0082 meter square. Calculate the force on the lid due to the air in the can. So force can be written as force is equal to pressure into area. So here the pressure is 102,000 Newton per meter square into area is given as 0.0082 meter square. So this meter square will get cancelled. After multiplying these two, you'll be getting the answer as 840 Newton. Next, a teacher demonstrates the behavior of waves by using water waves in a ripple tank. Figure 5.1 shows a cross-section through part of the water waves. So we can see here the total length that is been marked as 18.2 centimeter. Calculate the wavelength of the water waves. Use the information in figure 5.1. So how we can calculate the wavelength? So total centimeter it is given 8.2 centimeter. So how many waves are here? So from one top to next top, it is one full wavelength. So this is 1, 2, 3, 4, 5, 6, 7. So total 7 it is there. So we can divide it by total. 18.2 divided by 7. So we will be getting the answer 2.6. That is the wavelength. So this will be 2.6. The teacher places a pointer above the water waves as shown in figure 5.2. Three students use stopwatches to measure the time taken for 50 peaks to pass the pointer. Figure 5.3 shows the measurement. So we need to write the time. It is displayed here. So this one is 17.24. This is actually 17.14. This is 17.16 seconds. On the line below each stopwatch, state the time measured. It's already been written. Calculate the average of three time measurements. For taking the average, we need to add these three and then divided by 3. So 17.24 plus 17.14 plus 17.16 divided by 3. So adding, you will be getting 51.54 divided by 3. So it is 17.183 seconds. Calculate the frequency of the water waves using the resultant B2. So here we have got 17.183. So for finding the frequency, number of, actually frequency means that is number of complete cycles per second. Per second, how many cycles it is there. So here for 50 peaks, we have measured these 50 peaks. The average value was 17.183. So per second, how much it is? So we will be dividing 50 divided by 17.18. So we'll get per second what is the frequency. This is actually 2.9 hertz. Next, the teacher repeats the demonstration using different ripple time and obtain these results for the waves. So wavelength is 0.025 meter, frequency is 2.4 hertz. What is the speed of the wave? So speed can be written as frequency into wavelength. So frequency is given as 2.4 hertz and wavelength is 0.025 meter. So we'll be getting the answer 0.06 meter per second. Table 6.1 shows regions of electromagnetic spectrum. Two regions are not labeled. Complete the table 6.1 by writing the name of each region that is not labeled. So next to before visible light, the wave coming that is ultraviolet rays. and after infrared, that is microwaves. Complete the table 6.1 by writing the name of each region that is not labeled. That already we are done. State two properties that are the same for waves in all regions of the electromagnetic spectrum. So speed of the light will be, speed of these waves in electromagnetic spectrum will be same. Speed of the wave will be same for all the waves in this electromagnetic spectrum, that is 3 into 10 raised to 8 meter per second. And these waves doesn't require any medium. Do not need a medium for travel. X-rays are used in hospitals to check for broken bones. State one other use for X-ray. X-ray can be used to kill cancer cells. State one precaution taken by the people who work with X-rays. They need to wear a lead apron. Next, students are investigating the refraction of light as it travels from air to glass. Their task is to measure the angle of incidence and the angle of refraction at the surface of the glass block. So these equipments have been given. Glass block is there, paper is there, gray box is there. So describe the method for the task. You can draw a diagram. So you can keep the paper and you can keep the glass slab. Then you can pass the ray with the help of this ray box. So in the paper, you can draw the normal. The normal is been drawn. So the ray will pass, will strike at the glass block, then it will be getting refracted. So you need to measure this angle with the help of the protractor. This is angle of incidence and angle of refraction, and it is passing through out of this glass block. So you can mark all those things with the help of protractor. You can measure the angle of incidence and the angle of refraction will be same. Next, figure 7.2 and 7.3 shows two identical lenses, each forming an image. The images I1 and I2 have different characteristics. One difference in the characteristic of the two images is already given. I1 is very small. This is I1. It is very small. And I2 is, this is I2, that is enlarged. So this is your object for first figure. This is the object for second figure. State two more differences in the characteristics of the images. So I1, actually it is a real image. But if you are taking I2, it is not real, it is a virtual image. You can see here I1 is inverted, but I2 is not inverted here. I2 is upright. Figure 8.1 shows the electrical symbols for some circuit components. Draw a line from each electrical symbol to the name of the circuit component it represents. So this symbol, it is a symbol for heater. Next, this is the symbol for fuse. And this is the symbol for lamp. So what is the symbol of thermistor? This is the symbol for thermistor. Figure 8.2 shows a circuit including a battery, a fixed resistor R, and an ammeter A. The reading on the ammeter is 0.38 amps. The potential difference across the fixed resistor is 12 volt. Calculate the resistance of the fixed resistor. So for finding resistance, we can apply Ohm's law. So R is equal to voltage divided by current I. V is given as 12 volt and current is 0.38 amp. While dividing, we will be getting the answer 32 ohm. Calculate the electrical power in the fixed resistor R, include the unit. So power is equal to current into voltage, IV. Voltage is 12 volt and current is 0.38. So while multiplying, you will be getting the answer 4.6. The unit of power, it is watt. Figure 9.1 represents an atom of beryllium. The labels A, B, and C indicate three types of particles. So what is A? A is the electrons that is orbiting outside this nucleus. And B, it is not having any charge, that is your neutrons. And C, that is your protons. Complete the table 9.1. So type of the particle A. So here A means that is outside this nucleus, that is your electron. Sign of electron is negative. B is inside the nucleus. There is no charge for this particle. That is your neutron. Neutron is actually neutral, no charge or zero charge. There are several different isotopes of beryllium. State what is meant by isotope. So in the case of isotope, it will have same number of protons. Number of protons will be same. Or we can tell atomic number is same. And the number of neutrons will be different. It will be having different number of neutrons. That means mass number is different. Same atomic number and different mass number. That is an isotope. Figure 9.2 shows sources of background radiation that affect people. Rocks and buildings, radon gas, food and drink, region D. So such is the source of background radiation in region D. So it's normally cosmic radiation. The nuclear notation for an atom of radon is given. That is 86. Atomic number is 86 and mass number is 222. State the number of protons in the atom of radon. So This is actually the number of protons, atomic number, that is 86. State the number of particles in the nucleus of this atom proton. So number of particles in nucleus, that is the mass number, that is 222. Next, figure 10.1 represents the part of our solar system. So we can see here planet A. So what is planet A? That is next to the sun. That is Mercury, Venus, Earth, and next it is planet B's Mars, Jupiter. So take the name of the planet A and B. That already we are now named. That is Mercury, and planet A is Mercury and planet B is Mars. On figure 10.1, draw an X to represent a moon of Jupiter. Draw a line to show how this moon is moving. So this is Jupiter. We can just draw a circular path and mark X for representing the moon. State two ways in which the four planets nearest to the sun are different from the four planets further away from the sun. So planets near the sun are rocky planets. That they are called as rocky planets, and they're smaller. And the planets further from the sun, they are actually gaseous planets, and they will be little bit larger. Complete the following sentence. The galaxy that includes the solar system is called, that is our Milky Way galaxy. The dash includes billions of galaxies. Our universe includes billions of galaxies. The distance between the sun and earth is 1.5 into 10 raised to 11 meter. The speed of an electromagnetic wave is 3.0 into 10 raised to 8 meter per second. Calculate the time taken for an electromagnetic wave to travel from sun to the earth. So time taken is equal to distance divided by speed. So the distance is 1.5 into 10 raised to 11 meter divided by speed is 3 into 10 raised to 8 meter per second. So otherwise we can write it as 1.5 into 10 raised to 11 divided by 3 into 10 raised to 8. So 1.5 by 3 will be 0.5. 10 raised to 11 by 10 raised to 8. That is 10 raised to 11 minus 8. That is equal to 0.5 into 10 raised to 3. So after multiplying, we'll be getting 500. What is the unit? This was meter. This was meter by second, right? So this will be coming top, this meter, and this meter will get cancelled. Seconds will come on the top. That is 500 seconds. Thank you all. We will see in the next video. Bye.